All right, guys, so object literals are very, very useful. We've been using them throughout the course, but when you want to have multiple instances of the same object, that's where you can run into some issues with object literals. You just don't have that capability to create basically a blueprint. So that's where constructive functions come in. You also have classes, but underneath classes are still constructor functions and prototypes, which I'll get into a little later. Now, we've used constructor functions before. In fact, if I were to say const, let's say now equals new date, so date is a constructor function. Whenever you see the word new, we're basically initializing a constructor function. So here we're initializing this now variable to hold a new date object. Okay, now what we want to do is be able to say new rectangle or new shape or new user, whatever the object that we want to create. So I'm going to stick with my rectangle example, and we're going to create a, what am I doing? We want to create a function called rectangle, and we want to make the first letter uppercase. Whenever you create a constructor function, you want to have that first letter uppercase. That's a convention, similar to a class. Now, before I even put anything in here, I'm going to go ahead and instantiate a new rectangle object. So I'm going to call this rect1, and very important that we use the new keyword. So we want to say new rectangle. And if I console log rect1, you'll see that in the console we actually have an empty object, a rectangle object. We have a prototype, which I'll get to later, but right now we just have an empty object. If I were to not use the new here, then I'm going to get undefined because it's just a regular function that doesn't return anything, so I'm getting undefined. When we use the new keyword, there's actually 4 things that happen. So I'm actually going to paste those in here. All right, so once we use new, a new object, a new empty object is created. The constructor function is called with the arguments passed in. We don't actually have any arguments being passed in. The this keyword is set to the new empty object. Remember in the last video I showed you that in an object literal, if we have a method, we can use this to access other properties. So this is the same thing really, where we have this and it's set to the object. Now the new object is returned from the constructor function. So when we use the new keyword, the constructor function is essentially doing this. It's returning this. Okay, that'll actually give me the same result. Only this is implicit. We don't have to manually put that in. All right, now we can set properties. I could say like this dot name and set that to, let's say, rectangle1. Right, so I could just hard code it like that, and if I save, you'll see that now our rectangle object has a name in it. But usually you're going to want to have some properties that you set, so you can set them by passing them in. Okay, which means we of course have to have some parameters here. So let's say we want to take in the name, the width, and the height. Okay, and then what we'll do is we'll set the name, instead of hard coding it, we'll set it to the name that's passed in. And then the width, we're going to set the width property to whatever's passed in, and then we'll set the height to the height that's passed in, right? And then we'll come down here when we instantiate our object. Let's pass in, let's say rectangle 1, let's say 10 and 10. So now if I save that, we have a rectangle object that has a height of 10, a width of 10, and a name of rectangle 1. And of course, if I wanted to just get one of the properties, like let's say name, then I could just use the dot syntax, just like an object literal. Now I can also add functions or methods, just like I showed you in the last video with the object literal. So let's say this dot area, and we'll set it equal to a function, and we're going to have this return this dot height times this dot width. And then if we come down here and we do a console log of, let's say, rect1 dot area, save that, and you can see we get 100. Now this is a blueprint, so we can create as many objects as we want. So I'm going to just copy that one. Let's create another one. So we'll say rect2, and let's change the name of this one to 2, and we'll say 20, say 2010. and then I'll go under that. This one will create, say, 3. This one will have 3, and let's say 30 and 30. Okay, so now I can go ahead and console log here. Let's say rect2 dot name, and let's also do rect3 dot name. If I save that, we can see rectangle 2, rectangle 3. If I want to get the area, I could say rect2 dot area, and let's say rect3 dot area. Save that, we get 200 for 2 and 900 for rectangle 3. So I can create as many objects as I want now from this blueprint, from this constructor function. It constructs my objects. Now there's just a couple methods that I want to show you. So if we want to get the constructor of an instance of an object, we can do that with the constructor method. So for instance, I can say console log rect1 dot constructor, and if I do that, you can see it actually gives me the constructor function. And then there's also an instance of operator. So for instance, I can say rect2, and it's an operator, not a property, so we don't use the dot syntax, but we can say instance of and then rectangle, and if I save that, we get true. Okay, because rect2 is an instance. It was created from the rectangle constructor. All right, so that's how we can create constructor functions, add properties and methods, instantiate objects from them, etc. So in the next video, I just want to talk a little bit about some of the built-in constructors like string and number and so on, and compare them to the literal syntax and kind of look at the differences and talk a little bit more about boxing, which is where JavaScript adds a wrapper, an object wrapper around primitive values when we use certain methods and so on.